Dr. West, thank you so much for coming on an episode of my podcast. I really appreciate having you today. You've obviously had a wonderful career in forest mensuration and quantitative ecology, and thank you again for coming on today.
A pleasure, and nice to meet you, and may we say something interesting for your audience.
I think so. I think you are probably the furthest interviewee that I've had, being all the way across the world.
I did see an interview with a woman who is presently working in New Zealand. She's not a New Zealander, but that was the only foreigner I could find. The rest of them seemed to be Americans.
Yeah, mostly Americans, North Americans, and one gentleman from Sweden. Um,
Ah,
yeah, but I've been mainly focused here in the U.S., and I'm happy to branch out and hear more about mensuration in the world.
excellent.
Yeah. So why don't you tell me? I mean, for the people that know you, they've probably cited your works and read some of your books, but why don't you just tell me a little bit about yourself and your career?
Okay, I had an odd start, I suppose. In our last year of primary school, or elementary school, as you call it in America, we were asked by our teachers what did we want to do when we finished school. And I said I wanted to be a lumberjack. And all I envisaged was felling forest giants with an axe. But the teacher concerned was informed, unlike most, and he'd actually heard of forestry. And he wrote down forestry. And I never really thought of doing anything else. Had I my life over again, I would probably give some thought to other things. I like archaeology, I like paleontology, I like cosmology, I like theoretical physics, but I got into forestry. So when I left school, there was only one forestry school in Australia at the moment. That was at the Australian National University in Canberra. I grew up in South Australia, um, and you did a couple of years at your own university. We're talking the mid 1960s here, um, and so before your time. Uh, you did a couple of years at your own university, so I did 2 years at Adelaide University. Then went and did 2 years at the Australian National University in Canberra. Uh, I had a scholarship with the South Australian Forests Department. They grow radiata pine. I can tell you more about those in due course. Um, and so I had a 3 year bond with them. They gave me a job and I had to work for them for 3 years to work off my scholarship. At the end of that time, well, I started off as a field forester. And frankly, field forestry I found incredibly boring. I mean, you just tell the gang to go out and fix the fence or plant some trees or prune something, and it was all pretty tedious. Luckily, there was a, a research branch uh, in that region, and the guy in charge of that wanted a bright young person to assist him, and I happened to fit the bill. So that was my entry to research, and I spent a couple of years with him, then went back to university again in Canberra and did a PhD. And then again, I was lucky that I finished my PhD, and there was the chief scientific organisation in Australia is called the Commonwealth's Scientific and Research Organisation, CSIRO, Commonwealth Scientific and Industrial Research Organisation. And they had a forestry branch. And luckily, the guy in charge of that branch was looking for a bright young PhD graduate to do a particular job that he had in mind. And so I got that job. I worked in Tasmania, which I hope you all know is the island to the south of Australia. And I worked there for some 17 years. I was originally hired. I'd spent my PhD doing nutrition, zinc and copper nutrition of radiata pine seedlings. This job was to deal with a large data set that had been collected over many years in Tasmania, and he wanted someone to do growth modelling, which I knew nothing about. However, I started reading the literature, and he also wanted someone who could use a computer. And we are talking in those days of mainframe computers. So you had a whole room was a computer. The thing that sits on my desk today can do vastly more, vastly faster than that entire room of machines at that time. The other thing was, if you wanted to do anything with one of those computers, you had to write your own program. There was no software readily available. And so we all learnt Fortran. Again, many of you have probably never heard of Fortran. It was the scientific programming language at the time. It's very good scientific programming language, and you had to write a program in Fortran. I still use Fortran. There's plenty of things that you can't get software for off the present systems, and so I still write Fortran programs. So anyway, I worked there and became a growth modeler, basically. In the process, I met one of their other employees. He was a biometrician. He died in June this year, just before his 90th birthday. And American by birth, grew up in the Bronx, but had lived in Australia for many years. So most of what I know about statistics I learned from him. He's a very good applied biometrician, not a heavy-duty theorist. And I have worked on various biometric things with him over the years. His speciality was nonlinear regression. He's written a couple of textbooks on the topic. David Ratkowski, you may have heard the name.
Yeah.
And so his loss to me is terrific. We've worked a lot, particularly in recent times when both of us was retired.
Yeah.
So I worked there for 17 years doing various aspects of growth modelling and the growth behaviour. I guess I call my speciality the growth behaviour of trees in forests. Mm-hmm. And that's what I've worked on pretty much. I eventually got a job still in CSIRO, being the head of the Cooperative Research Centre for the Sustainable Development of Tropical Savannas. Now, the top third of Australia consists of tropical savannas.
Okay.
And it's all lowish forest.
Yeah.
So it's probably one of the biggest research areas there's ever been in the world. And I had to move to Darwin, right in the north of Australia, climate unsuited to human habitation, my wife and I decided. We had researchers sort of spread across all of Australia, contributed by various research organisations. Worked there for several years. Finally managed to get myself made redundant from CSIRO. Decided to move to northern New South Wales, which is subtropical and the weather is good, where I still live. And by sheer chance, the university in the town in which I live had started a degree in forestry. So I ended up teaching forestry for 20 years there as a contract lecturer. Just did my teaching and then went away and did consultancy work for many various forestry organisations around Australia. And then finally retired in 2017. But luckily, I have lots of old data sets and various things, so I have been very able to continue with my research. I found that retirement is a good thing for research because you don't have to do anything else,
Right.
and so it fills my time in very effectively. And so I'm very happy that I have been able to continue with that. So that's been my career, really.
Well, that's a lot of career in a very short summary. Hopefully, we can dive into it a little bit. I know retirement and getting to work on your own, project sounds just amazing. It sounds so much fun. I can't wait until I can do the same. Although hopefully I have plenty of time to, fill in the gap here. You know, I think the first time I was acquainted with your work, I was working on my PhD and I was working with um, the growth density relationship, basically working with loblolly pine because that's what we have here in the southeast US. And then I got into this idea. I didn't realize how complex forest density actually is. For us, density
Sure.
was a tree count or a basal area. And so then I came across I believe you wrote it in 1982, and it was published in 1983, your paper on the different measures of density.
Let
Yeah.
me just check which one you're talking about. 1983.
Yeah, that was
Oh dear, that is a long time ago, isn't it?
just a few years before.
1980. Oh yes, of course. That'll be the Canadian Journal of Forest Research
Yes, sir.
paper about density.
Hmm.
That's a very basic, fundamental stuff.
Yeah.
Yeah. Blah, blah. Oh, then there's, good heavens, tree suppression and the self-thinning rule in 1983. Comparison of stand density measures in even-aged regrowth eucalypt forests of southern Tasmania. That's probably the one
Hmm.
you remember. And it probably, of course, many of your um, viewers probably don't know much about Australian forestry. So perhaps I should say a little bit about that.
Yeah, please.
Of course, we are dominated by the genus Eucalyptus.
Mhm.
Uh, and there's 700 odd species of eucalypt.
Wow.
The taxonomists keep on trying to divide it into other various genera, as taxonomists are inclined to do. But basically, there's 700 odd species. A couple they're only in Australia, except a couple snuck into a Papua New Guinea when there was a land bridge between northern Australia and New Guinea. Otherwise, they're all in Australia. They're a very modern genus. They've evolved over the last 30 million years. Originally, Australia was part of Gondwana land, which was this great, one of the massive land surfaces centred around Antarctica, which hasn't really moved since then. It was covered in, because the Southern Ocean didn't exist, which keeps things very cold in Antarctica. It was a lot warmer. The whole continent was covered in rainforest. Dinosaurs roamed it
Mhm.
vigorously. And 66 million years ago, the dinosaurs were died out, And 30 million years ago, Gondwana split up, and Australia started moving north. The other southern hemisphere continents broke off, as did India. And Australia has moved north slowly ever since, as it still does by a few centimetres a year. It got progressively drier. Its soils, there was no volcanic, well, not much volcanic activity. Its soils were old and have got progressively less fertile, I guess, over time. And so the eucalypts evolved in that drying, relatively infertile, and what became fire-prone environment. So they're very much geared to fire in their natural environment. And so then this vast array of species developed, spread all over the country in various different forest structures. We have the tallest hardwood in the world, Eucalyptus regnans, or mountain ash as its common name is. It occurs in Tasmania and Victoria, so southern parts of Australia. It is rumoured that they once found the tallest tree in the world in Tasmania.
Wow.
They didn't discover it was the tallest tree in the world until they'd felled it. Ran a tape along it. I don't know how much truth there is in that story, but it has been repeated over the years. But there are still these over 100 metre tall eucalypts. They're inclined for their tops to blow out. So one day it's the tallest tree, and then the next day all of a sudden it's not.
Yeah.
But the redwoods beat them at the moment. I think the tallest redwood at the moment is about 106 metres, 109 metres anyway. So there are then, particularly up in the wetter areas of the coastal areas, up the east coast of Australia, southwest Western Australia, there are large areas of eucalypt forest which have been used commercially and managed for wood production for many years. But then there's this vast array of species spread everywhere, from the tropical savanna and through the deserts and so on. So that's the sort of, well, the forestry environment I grew up in was pine forests. Now, in the early first part of the 20th century, South Australia, where I lived, has very little forest. It's a dry environment. And it certainly has very little forest suitable for management purposes for wood production. And so in the early 20th century, they decided they'd see if they could find some pine species that they could plant. Hunted around the world, and the one they came up with was Pinus radiata. Occurs in a very limited area on the Monterey Peninsula in California and one island off the coast. I did take a trip up the west coast of America a few years ago. Now I got a Christmas present from my wife to go and look at the tall forests, which I did. And at the same time, I went to the Monterey Peninsula, and sure enough, there were radiata pine that I knew well and I could immediately recognise because they grew them in South Australia. And when I first started working after graduating as a forester, I worked in the radiata plantations in the southeast of Australia, which are pretty good and high quality forests for wood production. And so I have some fondness for radiata pine, Adford pine species, and as you say, your loblolly pine. And I must say, there's more papers about loblolly pine than any other pine species, I
Right.
think. And so I've read lots about loblolly
Hmm.
pine over the years. And of course, radiata pine has become extensively planted in various parts of the world these days. So I have this long time relationship with at least one pine species, shall
Yeah.
we say.
Yeah. Same here, just a little bit different pine species, although probably just extensively grown commercially as radiata pine, I would imagine. I mean,
More, even more so, I think. Yeah,
think so.
you've got vast areas uh, of loblolly pine all over the southeastern US.
And
Uh,
we've now planted it in Brazil, and it grows the best in Hawaii, apparently. Haven't seen it personally, but
oh, okay. Yes, I think I did. I have been to Hawaii to a conference there once, and I think we saw some pine
yeah,
plantings. But and of course, the eucalypts are now planted vastly all over the world,
right.
and so
And and I assume the in Australia the eucalyptus are primarily grown for pulp and paper. There, you can't do anything structural with any of them, can you?
oh well, no. By the timber quality varies a lot between species, and there's the perfectly highest quality
Hmm.
timber for structural purposes. Interestingly, of recent times, I've been seeing a lot of stuff coming via the internet about how they're starting to build skyscrapers out of timber,
Hmm.
and in many respects, it has some advantages over steel. I'm no authority on the matter, but it all sounds good stuff.
Hmm.
And there's plenty of eucalypts being used for that purpose. So it produces very high quality structural timber. Some that isn't.
Yeah.
They vary a lot in quality. Again, that reflects the fact there's 700 species of them.
Hmm.
Um, and so they're grown both, they're probably grown in Australia, they're grown more for pulp and paper than anything else,
Yeah.
but they're also grown commercially for structural timbers as well.
Hmm.
Um, but I guess there's more plantations in pine around the country these days that are grown for structural timber. The eucalypts they're a strong timber.
Hmm.
They're denser, a lot denser and tougher than pine timber. So no, they're a good species for growing timber. But in other parts of the world, I think they're being mostly grown for pulp and paper. In South Africa, say there were very extensive plantations of eucalypts grown for timber. I remember visiting there. God, it's back in the apartheid days, and no one went to South Africa at that time except forestry at a conference there.
Yeah.
Um, and it was terrible, I must say. Anyway, that's beside the point.
Yeah.
And so we saw some of these very extensive eucalypt plantations which had been grown there for timber production. It was rumoured that the entire plantation program in South Africa derived from one tree that grew in some diplomat's front garden, and they managed to get some cuttings from it,
Mm.
and they constructed all their plantations from the cuttings
Wow.
ultimately from that species. I mean, bizarre stuff,
Yeah.
really. But so no, I mean the eucalypts most commonly these days used throughout the world for pulp and paper,
Mm.
but have been and can be used for structural timbers, good quality structural timber if you pick the right species.
Yeah, I guess you have a lot
Mm.
of species to pick from. So,
Well, exactly.
we're primarily in the southeast U.S. competing with pulp and paper from eucalyptus out of Brazil, and so my
Mm.
question was really born in ignorance because I don't know much about the species. It does not grow well at all here in the southeast U.S. Along the coastal areas where it doesn't get too cold, but as soon as you have a freeze, the seedlings just don't survive.
Well, that's right. It's certainly not a good frost survivor.
Mm,
And so, yes, as soon as you get into the cold parts, I mean, I haven't visited America very much,
mm,
but I have seen some eucalypts around, just growing around California and whatnot in the sort of subtropical areas where the weather is good,
yeah,
and um, which uh, and they're fine, and they're sort of scattered around um, as nice, pleasant trees for people to enjoy. I must say, it's always a bit of a pleasure when I'm overseas and you come across a eucalypt and you feel like you're at home.
as a forester, I have to see all the arboretums in every place that I visit just because, and it's always funny to see a loblolly pine growing, as an exotic species in,
Sure,
various parts of the world.
absolutely, yes. Yeah.
I always see it and go, "Hey, that looks familiar. That can't be the one that I know." So you were born and raised in Southwest Australia,
South Australia, right?
South.
South Australia, you've got Western Australia occupies the western half of the continent.
Yeah,
South Australia is next to it.
yeah.
Then you have Victoria, New South Wales, Queensland on the eastern side. So South Australia and the Northern Territory occupy the central half of Australia.
It's not a. It doesn't look like there's a lot of forest in South Australia.
No, as I said earlier, South Australia has very little forest that you could use for commercial
Hmm.
purposes. There's plenty of eucalypts, but they're sort of the desert
Hmm.
type species and the drier country type species. Down in the southeast corner, where it's a bit wetter, and that's where they can grow the radiata pine successfully. You get some of the other species occur there, but again, not in large areas of um, commercial forest, really. Um, so that's why they ended up growing radiata pine, and South Australia was the first part of Australia that started to import exotics
Mm,
to make some forests
yeah,
there, which have been very successful. And radiata pine is grown all over the country these days, of course.
yeah.
Um, so yeah, there you go.
Mhm. So whenever you went to school and you got out and you were working your first job as a field forester, you said it was quite boring. For us here, all that we hear about Australia is everything wants to eat you. So how was it?
Ah, well, yes, we like to keep you on your toes in these in these matters. Now, I mean, for example, we're in those pine forests in South Australia. It's a lot of bracken fern, so sort of waist high. And there's a particularly nasty snake, the tiger snake, very venomous snake, sometimes sits on top of the bracken fern. And if you're wandering through the plantation, this can be a hazard. There are some extremely dangerous creatures
Mm,
in Australia, but by and large, they keep out of your way.
yeah,
We just like to make you foreigners frightened when you get here.
definitely frightened too much. Walking around by myself if I didn't know what was going on down there. It's
Well, that's right. I mean, there's plenty of. I live in a country town. Uh, I go out, go for a walk every morning, and occasionally I come across a kangaroo who's come out of the bush below and is eating grass from people's lawns. They run away as soon as they see me.
Yeah.
Um, there are koalas that live in the trees around my place. They can be rather noisy at night. Koalas, the male koalas, chat up the girls at night. Um, so there's and also one of the most deadly snakes in the world, the um, eastern brown snake, lives in this region. But again, it's you don't see them. They stay. Although I was talking to my GP one day, and he'd had one of his patients had walked into his shed. A brown snake had been sitting on a ledge and bit him, and he was dead before he got back to his back door.
Oh wow.
So they can be that deadly.
Yeah.
Uh, so anyway, it's I've lived my life without ever been really troubled by
Yeah.
these animals. But the rule is, if you see one, you keep your distance.
Right. I think I would have been very motivated to have a career as a biometrician if I had been born in Australia because I would not want to be out. I am deathly afraid of snakes, and if they were even more poisonous and deadly, I would be even more afraid of them. I don't like them. They're just and
Well, there you go. We grow up with them, so we come to
well,
grips with these matters.
we do too. They're here in the forest, they're around, but if you don't look for them, you don't.
You have bears and things. I mean, a
Yeah,
grizzly bear can be a pretty tough customer.
yeah.
And of
Where
course, whilst Australia did have some mega flora, fauna, they all died out so quite a long time ago. It's sometimes alleged that the original Aboriginal occupants used to kill them to eat them, but there were quite a few large animals, not mammals. I mean, and but they've all vanished from the Australian countryside. So we don't have nasty cat species, for example, as you do in the Americas.
mhm,
Um, so there you go.
yeah. Well, I'm curious. So you finished. You didn't like being out as a field forester. You went back to school. You obviously you went directly to a PhD. I guess you didn't want to do a master's program, or there wasn't a master's program. Was it common?
Well, they were, of course, but
Yeah.
you, as an undergraduate, you could do what's called an honours degree
Mm,
here, and it involves doing some research and writing a thesis. And luckily, in the forestry course, you could do your honours degree at the same time as you
mm,
did your regular 4 year degree. And if you got um, a, a good quality honours degree, you could enrol straight in a PhD without having to do the master's degree. If you hadn't done the honours degree, you'd have to do a master's degree first. But it meant I only had to spend 7 years at university in total, and not more, as
yeah.
those who did master's degrees have to do.
Yeah. I know some people that do 7 degrees for an undergrad, so that's
Oh
not.
my gosh.
Some people enjoy it too much.
Well, quite so. And
Yeah.
of course, I mean, in America, you have a large array of forestry schools and spread across the country. Australia these days has no basic undergraduate forestry school.
Oh, okay.
Several of the universities have toyed with the idea of developing such a school. The university I went to gave up its undergraduate forestry degree, and they do teach some postgraduate uh, elements, as the University of Melbourne started an undergraduate degree, but also has given it up. And well, I was asked the other day if a teenager, an Australian teenager, said they wanted to do forestry, where would you recommend they send them? And all I could say was send them to the University of Canterbury in New Zealand. It's the nearest forestry, regular undergraduate forestry school that's available in this region. When I was an undergraduate, we had a class of about 50 odd, with people from all over the world, really. The Pacific Islands, we had several African students, quite a lot of New Zealanders, um, and which made up the numbers. But the problem is that forestry is a small profession. You don't need that many foresters to manage the forests of the country, and so it's not a well-known profession, and that really is why it sort of disappeared from the universities. They just don't get enough students to enrol. The university I was at here, its forestry school was doing fine. And we were getting a lot of foreign students from Indonesia, India, Papua New Guinea, who were doing master's degrees, sort of postgraduate degrees, and they were good value to the university because their governments used to pay for these people to come there. The pandemic totally stuffed it.
Yeah.
And of course, they all stopped coming, and it just never recovered. And the number of Australian undergraduate students were never large enough to really keep it going. And that's why that school folded up. And so it just no longer exists. They're putting a vet school in its place, would you believe?
Wow.
So, there you go. It's a profession that, well, it's obviously much, much larger in America. And when I think about it, I mean, your forests probably don't cover more land area than our forests do, but somehow you end up with rather more people managing them. And I can see things like, it's clear to me that quite a few of the academics in America have been working extensively in the South American forest because clearly they're getting research grants from South American companies, and so they've been very keen to accept those grants. I did visit South America a few years ago now, and I was extremely impressed by their forestry there. It appeared to be very efficient. There are companies that were doing everything from seedlings in the ground to sawmills where they produced the finished product, and paper mills. And the one company had the lot. I mean, it was very impressive how efficient quite a lot of the people were. So,
which countries did you visit?
It was principally in Brazil.
Yeah.
Yeah, and there was a UFRO conference.
Yeah.
Some years ago, and did you go?
I didn't. I was in the middle of changing jobs from
Okay,
I was in
right.
Norway and coming back to the US, and so
Oh,
I didn't go.
I finally missed the most recent UFRO conference. Basically, I'm getting too old to traipse around on aeroplanes. It all gets very tedious. Of course, wherever you go from Australia, it takes 24 hours to get there in the aeroplane, and so it all gets very tedious.
Right. Yeah,
Yeah,
it's a very long way to anywhere from Australia, I can
it
tell.
is indeed. It is indeed. Yeah.
Well, so I'm curious, back to like when you finished your PhD and you started working and you were at CSIRO and they
Yes.
were asking you, to do growth and yield modeling. I guess this would have been in the early 70s, late 60s.
Yes, I went to Tasmania in 1977,
Okay, late
and
70s.
that's right. And stayed there until the middle of the 90s,
Mm,
um, when I finally went to Darwin for a while, and then eventually left there. And the data they had collected there was from Tasmanian eucalypt forests, native forests, or mostly managed native forests. And so I served my apprenticeship in growth modelling in by reading the literature and writing Fortran programs.
mm. Well, I'm
And
curious.
we're talking in the days when your Fortran program you put on punched cards, you fed the punch cards into this device. In this case, the mainframe was in Canberra. I was in Tasmania, but we had a punch card reader in Tasmania, and it would send this all off to. And of course, you'd make a mistake in your program, and this would end up in the output, and so you'd have to then correct the card and put the punch cards back in again, and it was all very tedious.
Mhm.
um, and it is extraordinary how well, to the extent that you've now got a computer on your phone.
Right.
I mean, it's just madness as far as I'm concerned. And the fact that you and I can talk like this is, I mean, the internet has been an extraordinary development,
Yeah.
um, in all aspects of science,
Mhm.
including social media, which is another issue, really.
Yeah, right.
Yeah.
Well, I'm curious though, during that time, how was biometrics and mensuration, particularly with forestry, how was that perceived in Australia, Tasmania? I mean, because I know, how it was here when people were working here in the US and kind of a lot of the models and things were developed in the US and Europe. So I'm curious in your part of the world, how did you see things going there? Were you getting the literature from here or was there internally biometricians working in that part of the world? How was
No,
it?
it was. I mean, everything I learned about growth modelling came from um, the literature.
Hmm.
So I had to start, and a large proportion of that, of course, was American literature and growth modelling. Uh, there was more from America than anywhere else, so that's really where I learnt my craft, I guess. Um, and uh, but then I mean, it became routine in Australia, and particularly when I worked as a consultant in the late 90s, early 2000s, a lot of work I did was building growth models for local the forest growers here, using them to look at management practices for things like thinning and whatnot. And so I just got into that sort of stuff routinely. And of course, many other people in Australia have become um, growth modelers and working on growth modelers. And I mean, I find it pretty incredible as to the extent at which remote sensing is starting to take over um, data collection now. I mean, I've written two textbooks, one of which was a mensuration textbook, and finally the third edition I had to add a chapter about remote sensing. It would be that was what 2014 or something. It's hopelessly out of date now. I mean, I can't be bothered. I wrote textbooks because I was teaching plantation or silviculture, plantation silviculture in particular, and forest measurement in the university here. And I thought, well, the university decided we wish to extend our courses to have them online as well as face-to-face teaching. And I thought about that. I said, well, what's the easiest way to get to online students? And you can write lecture notes and send them around. I said, well, why not write textbooks?
Mm-hmm.
They can buy the textbook and that gives you the course. So my textbooks were really written specifically to deal with the courses I was teaching at the university. And over the years, I did two editions of the silviculture text. And the silviculture text, I think I can safely say, is not out of date. It's plantation silviculture in particular. And I don't think that's really got badly out of date. But the mensuration text is well and truly out of date because this remote sensing has become so enormous and clever.
Mm-hmm.
Um, it's got to the stage where I start to wonder whether people like you who don't like going out into the bush, it doesn't matter anymore. You can get all this data from satellites and um, drones and the whole deal. I mean, you can even stick devices on the ground in the forest that measures every tree stem, fine detail from ground to tip. We're still not so good on roots, and so whilst you can do a bit of uh, root analysis with um, various remote sensing instruments, fine roots are tricky. Fine roots are too small.
Right.
You can't really get fine roots at the moment with remote sensing.
Yeah.
So there is still room to dig up root systems if you need
Yeah.
to know about that. Otherwise, it's starting to get to the stage where really you can get your measurements without ever going into the forest. Bit of a sad thing. I mean, a lot of people like doing forestry because it involves going into forests.
Yeah.
And so that's really a very substantial change in the profession, I think.
Mm. I do enjoy getting out in the forest, and I don't mind going to collect data. I just mean that I don't want to be in a forest where everything's trying to kill me. So, um,
Well,
and
that's right. Your average loblolly pine plantation is probably pretty safe.
pretty safe, yeah, generally. Well, I'm glad you brought up remote sensing and your two textbooks because those were questions that I had for you. I bought both of your textbooks, and for people that are interested, one is called Tree and Forest Measurements. It is a mensuration textbook. It is
It's
great.
had three editions, yes.
Yeah, I,
As I
I
say, it's now out of date.
yeah,
Uh,
I looked through it though. It is a great primer. When you say out of date, it is I think more of the
well, it's got all the basic,
yeah.
you know,
And
rudimentary things that you need to know if you're dealing with measuring trees. Yes.
I guess you're not getting a whole lot of royalties off this thing because it costs each of the textbooks cost me $14 US. So
Well, there you go. Well, funnily enough, I every now and then, and I'm trying to remember when the last one was, I do get a small amount of royalty still. I think the last one was a few $100 or
Yeah,
something. And but yeah, it's it's not a major source of income, shall we say.
yeah,
I don't think textbooks ever are. You
yeah.
spend an awful lot of time working on them to write them,
Mm.
um, and you never really get much return from it. But I'm sure the publisher does a jolly sight better than you do.
Right. Well, so your first edition of the tree and forest measurements was 2004, if I'm correct. Let me make sure I got those dates correct.
The last one was about 2014 or so,
Yeah,
15.
2004 was the first edition of the
Yeah,
tree and forest measurements, and then 2006, growing plantation forest. So
that's right.
you answered
Here
my
we go. I've got them listed here. What have we got here? Tree and forest measurement, 2015, the last edition. Growing plantation forests, 2006, and then a second edition, 2014. Yeah, and
so my
and
question.
again, it's a great way to do teaching.
Yeah, right.
You just say you guys get the book and you give a lecture that sort of comes out of the book.
Yeah.
And it's all good.
Well, that was going to be my question. What made you write a book, and then what made you write a book, and then want to write another book? So for
Well,
teaching
it
mainly.
just reflects the fact that I taught two.
Yeah.
I ended up teaching a third unit when one of the other lecturers left in ecophysiology,
Mhm.
and but that was towards the end of my teaching career, and I didn't end up writing a book on that one.
Mm.
So that was my third teaching experience, and I mean I was always interested in plant physiology. I remember as an undergraduate, um, I remember being very impressed by this is at Adelaide University doing botany at Adelaide University, and I was very impressed by how much the lecturers knew. And I thought, God, maybe one day I can know as much as they do. Um, and but I got interested in plant physiology, and I ended up doing a PhD in zinc and copper nutrition of radiata pine. Uh, zinc, zinc and copper deficiencies occur in young radiata pine in South Australia. Soils just don't have enough, and in the first few years, the plants can't pick up enough zinc copper, so they spray um, copper sulfate and what on the trees and zinc sulfate, I think, on the trees to give them a bit of a boost. One of the most interesting experiments was done by a colleague of mine who worked in that research group in South Australia, and he did experiment. A lot of phosphorus and nitrogen was used as fertilizers in those plantations, and he had done an experiment where he put large amounts of phosphorus and nitrogen as one of the treatments, and the trees were growing like mad. And all of a sudden, they started bending over.
Mm.
And it actually ended up, there were some trees that ended up with a loop. After a few years, they recovered and they started growing normally again. But some ended up with actually a loop
Oh,
in
wow.
the stem. Um, there is one paper on the subject written by this guy who was an odd, not high level scientist. Anyway, uh, what had happened was that after a few years, they were growing so fast, they just ran out of copper in this case.
Mm.
And copper is crucial to maintaining the strength of timber, of the wood. And so that's why they were bending over. Um, but then after a few years and their growth rate slowed down a little, they could then get enough copper out of the soil, and so they recovered and started to grow upright again. But some ended up with this loop in
Yeah.
the stem. Um, so it was a perfectly acceptable topic for a research project in a PhD in Australia at the time. And but then I ended up getting a job that involved growth modelling. So I never went back to physiology. But however, I'd had a bit of a background in plant physiology, shall we say.
Yeah.
And so there you go.
That's good because it probably set up a lot of the research that you eventually did. Because if you look at a lot of your papers, they're focused more from the ecological side, not necessarily from like a pure mathematical standpoint.
That's right. I think things like looking at things like what causes tree stem shape.
Yeah.
I mean, if you're a biometrician, you do boring papers on taper,
Right.
uh, and in fact, there's one at a journal at the moment where a colleague of mine had got some data from plantation growers in Australia, and he had another colleague who was working on a taper model for them who died. So they asked me, would I have a go at the taper model? So we did what I consider an extremely boring taper model. There's thousands of taper models for every species conceivable around the world,
Yeah.
and this is just another one.
Mhm.
But things like why are tree stems shaped as they are? How does their strength vary along the stem? Why do they end up with these particular shapes and this bulge at the bottom and all that sort of stuff?
Mhm.
And that all has engineering slash physiological origins.
Mhm.
And so it's those sorts of things that I've been interested in over the years to keep up that those things about physiology and the physiological behaviour. I mean, at the moment, I'm beavering away on self thinning.
Mm.
And yesterday, I have come across something very odd. I'm not quite sure what it means. I was trying to work out what my results were telling me, and I came across something even odder. And well, now, once I finish talking to you, I shall go back to try to work out what the hell all this means and whether it has any origins, particularly in the competitive inter-tree competitive
Mhm.
processes, which is something I've been looking at quite a lot over recent years, is how trees compete with
Mhm.
each other
Mhm.
and how you can measure the level of those competitive processes. And again, there's a lot of very tedious papers around where people have used very simplistic models of competitive processes, and they're perfectly useful for as part of a growth model,
Mhm.
but they don't really tell you much about how the competition is occurring. And I'm much more interested in exploring some of those more basic biological issues.
Mhm.
Um, so that's how I fill in my time these days.
Yeah, that's interesting. I think from what I've seen, what most people are using is something like a relative stand position or a crown competition factor.
All that stuff, yeah. And you'll find lots and lots and lots of papers where they use those things without really working out why is this happening. Is it, and what are the trees competing for? You, they start off early in their life competing with what's in the soil. When their root systems get large enough to overlap, then some get taller than others, and then competition for light starts and some of the small trees get suppressed and eventually die, and that's where it leads to the self-thinning
Mhm.
rule. And which again, there's a lot written about, but there's a lot of elements, I think, as to why it happens and how it happens
Mhm.
that we don't understand, and those are the elements I'm more interested in
Yeah.
pursuing. And funnily enough, well, I think in an email to me the other day, you mentioned Reinecke's
Mhm.
density index, and Reinecke is very well known in the forestry world for self-thinning issues. And my magical discovery yesterday suggests that Reinecke is rubbish. And it absolutely serves no particular purpose, and I'm shocked.
Mhm.
Anyway, that's what research is all about, trying to come up with something new.
Yeah. And another gentleman that I mentioned was Dr. Boris Zaidi, and we had a we had
Boris, yes,
a
yes.
similar idea. I never got to meet him. He passed back in 2014-ish as well, somewhere around.
Okay.
Getting through some of his papers, he was very mathematically inclined.
He's a funny author.
Yeah.
Sometimes I'm not quite sure where he's coming from or how he got there,
Mhm.
and whether it really means anything.
Right.
But he's a funny author. And
Yeah.
so, well, I'd like to talk to someone who did meet him
Mhm.
and who knew him, and whether he was a bit strange
Yeah. I
as he comes across in his papers. Yeah,
I have a friend who worked with him for a few years and worked together on some of their same research.
you're right.
I can introduce you, and you can have, you
Well,
know,
I'll certainly be interested because
yeah.
I mean, he did an enormous amount of stuff,
Mhm.
and he tried to venture into all sort of areas of tree growth behaviour, and some of it's all perfectly interesting.
Yeah.
But it's always got this sort of slightly strange feeling to it. So there's no one else quite like him, really.
Yeah. Uh, I definitely think not, and I think he tried to approach modeling kind of not similar to you, but in a different way than a lot of other people's approach, not purely mathematical and data driven, but trying to think about how those processes worked.
That
It's
absolutely, yes,
my
yeah.
understanding that
What was happening and how it was
yeah,
happening. Yeah, yeah, yeah.
he walked from his house to his office, and he was at the University of Arkansas at Monticello, and he walked from his
Right.
house to his office at the campus every day. And apparently, in his walks back and forth, he was just postulating these ideas. Why are things growing, the way they are? And that's
Well,
how.
it's interesting you say that. I mean, as I said, I go for a walk every morning, and often I find myself composing what I'm going to write in the paper I'm working on
Yeah,
today, or what the hell did that thing I was looking at yesterday mean? And
yeah,
so I spend quite a lot of time thinking about forestry issues on my morning walk. So
yeah.
there you
A walk through the forest is good medicine. It's good for understanding your thoughts and putting things together. Although it can
go. Quite
be
so.
getting
That's,
lost in your thoughts can be quite intimidating sometimes because then you got to follow up on them.
well, that's right. Yeah. Yeah.
Yeah. Well, I'm curious for you. I me being the kind of next generation of forest modeler, we have all of these people that have come before us. You being one of them. I'm curious, who are some of the people that you admired in your career, and do you have any good stories to share?
Well, it's interesting you ask that because um, I have spent little time out of Australia. Um, I mean, I've travelled to various parts of the world to conferences and this, that, and the other, but I haven't spent any extensive uh, time nor have I particularly spent time working with overseas colleagues. Interestingly, you may have heard of a guy called Oscar Garcia.
Mm-hmm. Yeah.
And Oscar used to work in New Zealand, the research branch in New Zealand, and I actually visited there for a month when I first started working for CSIRO. The boss said, go and talk to the New Zealanders and maybe you can get something going with them. So I met Oscar there. I haven't really had anything to do with him subsequently. He was in Canada for many years. These days, I think he's gone back to Spain. He had origins, Spanish-speaking origins, I think. And in my current work, I have been looking around. I was looking around for forest growth models which make no assumptions about self-thinning and see if they produce the self-thinning results.
Mm.
Because if they do, it means maybe you can tell something about how and why it's working. Well, Oscar's model was one of the very, very few I found that you could really start to use for that purpose.
Mm.
And so it's that sort of thing. And so that's what I've been using recently, and magically it produces all the self-thinning results that we know occur, but it is simply built on using functions that we use to fit the data and didn't make any assumptions about self-thinning processes, whereas some forest growth models assume the self-thinning process is going to occur, and so they have functions that reflect that as part of them. So it's that sort of thing where I've used work that other people have done overseas, but I've never really worked much with them. Binkley, I've used to have communicated with sometimes. I did a bit of a research project on sampling, forest sampling, slipped into the biometry there. He had done an interesting paper on where he was trying to work out, it was a biomass, I think, and he'd used a particular sampling method. So I ended up doing some simulations of that based on the forests for which he had published data. And so I communicated with a guy like him a bit on that sort of stuff. But otherwise, I haven't really worked much with people outside Australia. A few local people here that I have worked with from time to time over the years, including my biometric friend with whom I've published stuff for many years. Interesting things like there is a fundamental problem in analysing data where you have repeated measurements from, say, the same plot has been measured on many occasions, or you've measured a tree and you've measured different bits up the stem of that tree. When you start to apply regression analysis for one thing or another, those repeated measurements lead to some intercorrelation amongst the residuals. And the result is you underestimate the residual variance and the mean square error of the parameters and whatnot. And so my colleague and I, we're talking back now in the 1980s, I suppose, we were mucking around with this problem but it was way, way beyond our ability to come to grips with the theory of this. So we found a colleague in CSIRO who was a heavy duty theoretical statistician, and he did the theory,
Mhm.
and it's all published. And I have the Fortran programs with which you can apply this theory, and it solves the problem. But interestingly, other things have come along in subsequent times, seemingly unrelated regression. All these sort of new developments have made what we spent all that time on not worth bothering with anymore. There are other systems that do the same thing.
Mhm.
And so, more recent times, what you did all those years ago has become completely irrelevant.
Right.
Such is life, I guess.
Yeah. I was curious when I read your paper on state space models in eucalyptus if you had any connection with Oscar Garcia because he is the state.
Well, interestingly,
Yeah.
I mean, Oscar is quoted in that paper, of course,
Yeah.
because that was certainly um, his field, and I guess this model of his that I'm using at the moment is a state space model,
Yeah.
and well, I've been very impressed by what a good job it does,
Yeah.
and so yes, that's right, and my state space model is well, it wasn't enough data. And if you start to grow the things too long, um, the variation starts to get too great, and you can be unsure of the long-term estimates.
Hmm.
But Oscar's model is a lot better in that respect.
Hmm.
I think he had a lot more data available to build the one I'm using, which is
Yeah.
a very impressive piece of work.
Yeah. I'm very interested in the self-thinning as well. And especially with kind of projecting past what we would consider traditional rotation ages because that's where interesting things start to happen. You know, the trees follow kind of that line. You know, as they're increasing tree size, they're decreasing tree number. Then you get to a point where they don't follow the line anymore. They start.
That's right. And they start to go further down. That's right. And I mean, there is one paper which has come up with an interesting function to attempt to describe those three parts of that curve, and that their method of fitting it is, I would have to say, bizarre. And I think I've come up with a better method, but I also don't think I need to use that function. Again, my colleague and I have been using the bent stick model, which gives you a nice sort of curve which goes into a straight line um, when you get further along it. So you can get a nice self thinning line out of it. So that's the function I've been using of
the
recent.
the paper you're referring to was that Vanderschaft?
Uh, Burkhardt
Yeah, Vanderschaft.
and Vanderschaft. Yes, I think that's right. Yes,
Yeah,
yes.
that Vanderschaft Curtis, he is my friend that worked with Dr. Boris Zaidi, the one that I said I would introduce you to.
Oh, okay, right. Yes, because he's been around for a long time.
Yeah, Curtis
And
is
of course,
years older than
Burkhardt's been there forever,
I. Yeah,
and you knew him
yeah,
too.
yeah. Burkhardt was my advisor. He was also my
Okay.
PhD advisor. He was also the PhD advisor of Curtis
Is
Vanderschaft.
he still alive?
Now he passed in 2022.
Oh, okay. So relatively recently,
Yeah.
yeah. And I mean, he was one of those people. There've been a couple like him, I think the rule was if you worked in his lab, his name had to be on the paper. And
Yeah.
I mean, his list of publications is so enormous. He couldn't possibly have written them all.
He definitely played the role of co-author, though. I mean,
Yes. Oh, very much so.
he
Yes.
did a very good job of giving advice,
Sure.
editing, all of that sorts of things. While he
Sure.
never was the when he was a co-author, he didn't primarily author the papers, of course.
Sure.
He did a few of his own papers in the end, but mostly it was graduate
That's
student.
right. I have noticed some fairly recent things with Burkhardt as the first author.
Yeah,
And so
yeah.
obviously, as he drifted into retirement,
Mhm.
he started doing what I
He
do.
he never retired.
No?
He worked until the end. He
Okay.
passed away in his office. He didn't quite make it to his desk coming back from exercise, is what I understand. So
Oh, okay.
he
Right.
definitely
Right.
gave his life to the profession. That's
Yes. 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 Yeah.
and also an amazing advisor. Just knew every student was different, and so let us have kind of not really free will, but let us find our way. So
Okay.
yeah,
Yes. Yes. Which is the best type of
yeah,
advisor, really. Yeah. Yeah.
exactly.
And I mean, of course, your PhD system in America. Well, I'm glad I didn't have to go through it myself, as in we, as in Britain and other parts of the world, you just do your PhD by research
Mhm,
alone. You don't have to go to courses and pass exams and do them. What must be the most appalling experience of all is when you have to defend your thesis,
mhm.
and anyone can come along and ask you anything they want.
Yeah.
Um, I mean, in my time, the university did actually get the examiners to come and interview you. Um, and that was confronting enough.
Mhm.
As for defending the thesis to whoever in the university wants to turn up, must be an extremely frightening process.
Yeah, it was not fun. Whenever you finish that, you don't feel like you don't feel success when you're done, even after you pass. You just feel, I don't know, depleted.
Relieved.
Yeah, they just take you to the point where you think you don't know anything because they're testing the limits of your knowledge, and so,
Okay, right,
yeah,
all right. Yeah.
some people might have had a different experience than I did, but you leave there just feeling deflated, like,
Well,
I don't
all those I've read about, it always sounds like a very intimidating
yeah,
thing. Yeah.
yeah,
And
and, unfortunately for me and for others, it takes a couple years after that just to get your self-esteem back. I mean, it's really tough.
oh, it's interesting you say that. Yes, yes, it was. Yeah, as to how demanding that makes it. Yeah,
Yeah,
and yeah,
but
well, there you go.
I was fortunate though to experience, other parts of the world as I went to Norway and got to see a lot of Europe and how their systems work, and I really enjoyed that. And
Okay.
yeah,
Yes.
even recommend people here if you want to get a PhD to, get over to Europe where I mean it pays well and it's a good experience and
Sure.
yeah,
Yeah. Yeah.
yeah,
I mean, there were PhD scholarships, government scholarships readily around when I was, and of course, in Australia, in my university time, formally speaking, there were fees at university, but the the Commonwealth government used to give so many scholarships to anyone who did reasonably well in their high school exams that you never had to pay the fee. So the large proportion of Australian students never had to pay university fees. Um, and of course, that's all changed these days, and people end up with these enormous debts, as they do in America, after paying these appalling fees, and it must be very depressing to live with all that debt.
Yeah. I
Um,
I didn't have a lot of debt, but it still wasn't fun to have any
Paying
of
it off.
it.
Yeah, yeah,
And especially when you can go to Europe, for example, and have essentially a free education. I mean, there's some
that's right.
fees, and they pay a good wage. I mean, in the U.S., I mean, at least in my experience, most people just had a very low wage and then racked up this enormous debt. It's actually the system just feels very broken. It's not a nice.
And I think it's much the same here, but it's always been the case in America.
Yeah.
And you've always had these enormous fees to pay. But certainly in my case, I was lucky in that I mean, I got a scholarship to do my PhD, and they just give you enough money to live reasonably and all the rest of it. And then I had a scholarship from the South Australian government as an undergraduate, which also gives you enough money to live perfectly comfortably.
Mm,
And so basically, I got my entire education for free.
yeah.
Uh, and well, I feel for people these days who don't.
Mhm.
It must be a lot harder. Yeah.
Yeah. Well, unfortunately, we can't recommend people to go to Australia anymore because apparently there's no programs.
Well, exactly. That's right. It's certainly not the. Um, I mean, you can go to university for postgraduate purposes, but I don't know for your average American PhD
Mm,
student there's anything in particular that they want to come to Australia for. I mean, again, the number of people involved and available to act as PhD supervisors in the world of forestry is limited,
mhm.
simply because it's a fairly small profession in this country. Um, and that's just an inevitable consequence of the forest circumstances and the population, basically.
Mhm.
America, you've got this vastly greater population, and that makes a big difference, I think.
Yeah,
Yeah.
I think we're seeing maybe the number of mensurationists and biometricians decline. I say that maybe I should just say traditional forest modelers. I think we're moving
Sure.
on to maybe other aspects, more of the geomatics, the remote sensing,
I
that
think that those elements are making a real difference.
right.
Yes, and they will certainly be altering the world of the forest scientists, basically. Yeah, yeah, and uh,
Yeah, but
and
it's
no doubt your world, I guess, is starting to be influenced by those things.
yeah. I think it leaves a lot of room for forest modeling because now, I mean, we're still going to have to forecast inventory data. We're just going to have a different type of inventory data that we
Absolutely.
have.
Yes, yes, yeah. Yes, I don't think those principles of predicting wood availability is certainly not going to go away, and so that's going to continue fine. But the data on which it's based is going to be very different.
Yeah.
Yeah,
And now, and I saw, you similarly worked in estimation of biomass and carbon stocks. I mean, now with the climate change and the world is just up and down over carbon and improved forest management and all of that. Now we're having to use models based on a very short time frame of data because we have short rotations, and they now want to extend those rotations out 20, 30, 40 years, and we're having to explain why that extrapolation might not work so well. um, the
well,
South
that's right.
China
Yeah.
is a good example because you're following the line. If you extrapolate, you keep following the line, and you don't get that drop off that you
All
otherwise.
that stuff. Yeah, of course. Yeah, that's
Yeah.
right. And you know, extending your model outside the range of the data on which it was built has always been known to be a dangerous practice.
Yeah. And it's interesting because it happens all the time, and regardless of the warning signs, I see it everywhere, and you just have to wonder why people don't are not more suspicious of the results that they're seeing. But I guess they
Well,
tell
quite,
them.
yeah, yeah, yeah. I mean, it's interesting that again, this model of Oscars that I'm working with, he had a very it goes up to 70 odd years of age from very early ages. So it's a very extensive data set, which I feel some confidence with
Mm,
applying over an extended period.
mm,
Um, but there's an awful lot of models where that's not the case, as you say.
right, right.
And so that's been part of my problem in finding models. I mean, when you look through the literature, the number of growth models, either of stands or individual trees, is staggeringly large.
Mm, yeah,
But when it comes to actually using them, they often are rather limited in their range. And you can't really use them for long term analysis of what's going on and feeling confident about the results.
right.
Again, I only wish this particular model of Oscars went to older ages, and I've in fact have extended it. I mean, I've just gone and grown it for longer, and it appears to be behaving perfectly agreeably, but you know full well you can't rely on it once you get outside the range of its data. So that's life, and
Yeah,
it's that sort of thing, that bend in the self-thinning line at later ages, um, which vanish
yeah,
when you haven't had the full data set to those ages
yeah.
to work with, which all fits in with Binkley's study of forest growth processes.
Mm. I'll have to check that out. I was seeing you have no, that's not a Binkley. Do you have a paper that you've co-authored with Binkley?
Well, there's one I did which used, see if I can find it now. Uh, Here we go. TAM review, sampling to estimate the frequency distribution
Mm,
of tree diameters or ages across large forest areas. Now, that was the paper I did, which did simulations based on the sort of inventory that Binkley had done. So there's much quotation of his
mm,
stuff, but it's not co-authored by him or anything. I've never written anything with him. I've only ever
yeah.
communicated with him. Yeah, yeah, yeah.
I see you also worked with Arnie Pomeraning and Hubert Sturba.
Oh well, yes, that was a that was a bit of an odd. Let's see, what's it called? Sampling theory inspires quantitative forest ecology. The story of the reloscope kernel function. Well, I'm having difficulty remembering the details of this because basically it's one of those cases where I had some good data
Mm,
that they could use. And so that's why I'm the third
mm,
author, is whilst those two have done a lot of stuff, and this sort of that paper followed on a bit from previous work they'd done, but and I remember contributing discussion to various bits and pieces of it, but basically I'd supplied some data.
mm,
And of course, you get these papers. I think the most authors I've seen in a paper is there's been about 200 authors.
yeah.
I mean, it's ridiculous. And of course, a large proportion of those people have maybe contributed a bit of data.
Mm,
And so they still end up with their name on the. It's a bit tricky if you have to quote the paper, and
Yeah.
the journal insists on showing all the authors.
Mhm.
And so, I mean, there are some things have just gone silly
Yeah.
in that respect. And of course, I am finding that the this open access business, the number of journals is increasing out of sight. Um, and I assume people end up paying the open access fees through their research grants. For people like me, it's a bit tricky because we don't have large amounts of money available to pay such
Right.
things. But luckily, the university library, I mean, I remain attached to the university I worked in, and their library, together with other Australian libraries, have relationships with some of the journal publishers, which allows you, because those libraries pay the publishers for access to the journals for their staff. And there's also sometimes you can get your paper published open access through that system
Mhm.
without having to pay for it. And I mean, as far as I'm concerned, the publishers are incredibly exploitive of scientists. I mean, I get review requests all the time, and some people, it's beyond me that they do reviews and they nitpick all this stuff in your paper, and you say they must have spent hours mucking around with all this nitpicking stuff. And I mean, my approach is, well, just before I was looking at my emails, just before talking to you, and there was another review request. And my approach is I will read the paper as an outsider, make a broad general view of whether I think it has any content. I'm not going to spend all day doing it.
Mhm.
I get no reward. I'm perfectly willing to write a thing that says, I think this paper is good, bad, or indifferent, and give a few brief comments as to why. But I'm certainly not willing to spend all my time when you get no reward for it.
Yeah.
When the journals have been making money out of authors and reviewers all my career,
Yeah.
and you never get anything for it.
Right.
And although of recent times, again, my co-author, my biometrician friend, had done quite a few reviews with one journal or another, and he'd been offered a free open access. So the last papers we did went to that journal because we got free open access. um, but the publishing industry is extremely exploitive of
Yeah.
scientists, and I've always been pretty unimpressed. Whilst I accept that it's very worthwhile, you have to do reviews. So much is being published these days, and there's even the occasional journal that says, you can expect the review within the week of. You say, now, come on, there's something going a bit off in all this.
Yeah.
And so the theory of peer review is starting to get a bit iffy. But
Yeah.
I can't believe that with all the stuff that is being published these days, that it's being reviewed properly
Yeah. I think
by
most
competent
of it is
people.
not. I try to review as much as I can. Maybe a paper a month at least.
I
There,
do similar sorts of things, yes.
there's a journal. There's a couple journals that I've just stopped reviewing for because they just publish rubbish. It's
Yeah.
just pay it.
I've sort of adopted the open access only journals. I won't review for. I'm
Yeah.
willing to review for some of the older, more established journals where you have the option of open access or not,
Hmm.
and I'm still do reviews for them. But otherwise, I think things are getting well and truly out of hand.
Yeah.
And I mean,
Well,
things like my understanding is that any Chinese scientist um, to advance in his career, he has to publish in English
mm,
in some of the better journals, and this has led to an enormous um, expansion of publications coming from China.
yeah.
Some of them perfectly respectable, and I've got no complaint
Hmm.
with them. But you think, how do they manage to write so much?
Hmm.
But then I suppose there's a lot of Chinese.
Yeah. Right. And I think it's interesting you mentioned nitpicky reviewers. So I actually reviewed one of your papers. You ended up publishing it in Forest Science. It was the calculation of a growth
God,
statistic. I think
yes, that's some time ago.
you
Yeah.
had originally put that in a different journal. I don't remember which one it was. And I was one of the reviewers, and I thought it was a great paper. And then another reviewer very much nitpicked it.
Okay.
It was rejected.
And it's also, I know the paper you mean, and it's also a paper that's quoted quite often because it's
Yeah,
ultimately it gives a very simple formula to do what you have to do,
I
which
think.
again Binkley
Mhm.
had used that process in several of his papers and never given the formula.
Yeah,
And eventually I worked out what the hell he'd done. So I said, I write a paper on.
yeah,
I mean, it's just crazy stuff, really. But
yeah.
you end up doing these things.
Well, so I'm curious, what's you've had this long, wonderful career. You're now in your retirement age, writing your own papers, doing the fun stuff for you. But I'm curious, what for you has stood out as, the most surprising thing that you've seen in our field in the past 40 years?
Oh gosh, that's um, I think probably the most surprising thing is these measurements in developments in measurement,
Mm,
and what we have been getting with everything from satellites to drones, and what the long term effect of that will be, I'm not sure. The other development that is staggering is climate change and the fact that virtually every paper that comes out of much of the world these days, somewhere it mentions climate change, and presumably the research grant has required that it have elements relevant to climate change
yeah,
in it. Now, whilst I can appreciate that climate change is a problem and things like that disaster in Texas in the last couple of weeks is the consequence of what's been happening.
mm,
Um, and uh, but the fact that it seems to be driving so much by way of research, much of which doesn't really have to do with climate change, but it makes sure it mentions it as
right,
being relevant in
right,
the paper. And those sorts of things you get a bit, well, you say, come on, this is, you're
right,
really doing research in something else.
yeah,
But clearly your research grant required you mention it.
yeah,
So I suppose that's, and of course the other thing that is staggering is the computer development. and our ability. That, I suppose, above all. I remember my predecessor in my job at CSIRO, who'd actually been supervising the collection of data that I was hired to um, end up using. Uh, he his filing cabinets were in the office I was in with all his old files there, and I remember looking through them. And he had gone on a sort of sabbatical. It was really his holidays. They wouldn't actually let him go at a sabbatical. He had to take holidays. And he went to Oxford University, where they had this new machine that would do calculations. And so he ran some of his data through this machine, and he was very taken with it. My past colleague, my long-time biometric colleague, um, the first computer he used, you used to program by doing plugs. You put plugs in. Now that's getting back to the basic computing days. Now, I mean, what has happened, both in the computers themselves and the advent of the internet, have made staggering
Yeah.
changes and ones. And I mean, I couldn't work effectively in retirement as I am able to because those things exist. So I can look at publications easily, I can find publications easily, I can do the massive sums that you sometimes need easily. And I mean, those changes are staggering, really, over over my lifetime.
Mhm.
Yeah, and I guess people of your age, you, it's well, basically since Bill Gates came up with the good stuff,
Yeah.
and from then on, things took a major. I will admit that Apple invented the mouse. The mouse is a pretty clever invention, I think.
I think so too. Yeah.
So that's what I suppose I can see has changed so enormously
Yeah.
over my uh, lifetime. Yeah,
Yeah, it'll be interesting to even for me to see how things are in 20, 30 years. I mean,
absolutely. Yes,
you
yes.
know, it was my generation. I am an older millennial, so we had the first computers at home. We had the
Sure.
first internet at home. And I've gone from seeing that to where, computers had megabytes of memory to now having terabytes of memory. And
And
so,
they're fast.
yeah, and they're fast. And
Yeah. And
I'm the worst.
they outstrip anything I use as a mainframe by a mile. Yeah.
I get upset when simulations take minutes, and I should just be happy
Well,
with
that's right. I mean,
it.
a lot of consultancy work I did where you'd be looking at things like try different thinning options.
Mhm.
And I mean, my computer would be running overnight and for days to do the sums.
Yeah.
And you know, we're still talking the 1990s, really.
Mm.
Well, the machine I've got today, I'm sure would do the same. I mean, I can't believe it. I pressed the button, I pressed return, and virtually before the fingers come off, it's done the sums.
Yeah.
I mean, it's staggering the speed of it. Yeah, and as you say, the memory amounts are vast.
Mm.
And again, yeah, how did you ever get by with less?
Right.
Yeah.
Well, Dr. West, I want to thank you for coming on the podcast today and telling your story. It was great to meet you and to talk with you.
Well, I hope it's of interest to some other people, and nice to have met you.
Yeah.
And thank you for having me.
Again, Dr. West, thank you for coming on the podcast, and thank you everybody for listening. Till next time. Bye.
See ya.